All right, so again, I'm given the derivative graph, and the f of x is continuous for all reals. I say it down here. So all numbers are fair game for critical numbers. So the derivative equals 0 at x equal -4. That's where the numerator is equal to 0, correct? All right, so then the derivative doesn't exist where the denominator is equal to 0. So that's going to be at x equals 0, oops, and x equal 2. All right, so I want to, and that's going to be answering this part of the question. So first off, this question is asking me, is it increasing or decreasing at 8? So I just need to find out if it's positive or negative at 8. So positive in the numerator, positive here when I plug in 8 to the 1/3 power, and then 2 minus 8 to the 2/3 gives me a -6 to the 2/3. The power of 2 squares it, so it's going to be positive. So this is all a big positive, so therefore it's increasing. Since the derivative is positive, the graph is increasing at x equal 8. All right, so these are the given critical numbers. So x equal -4 and 0 and 2. All right, so then I'll need to make a number line to determine what's happening on either sides of the critical numbers. So I've got -4, 0, and 2. So at -4, the derivative is 0. At 0 and at 2, the derivative doesn't exist. All right, so I'm going to pick a number like -5, and find out using the derivative, right? Using this function, the derivative, is it positive or negative? I get a negative in the numerator. The cube root of -5 would be a negative. And then this 2/3 power is always going to make it positive, correct? So it gives me a positive. So all told, this gives me a positive. All right. Now I'm going to go check, see what's happening at -1. So back in between -4 and 0. So I plug in -1 in the numerator, I get a positive. Cube root of -1 is negative. And then this 2/3 power is always going to give me a positive. So I do get a negative. So between -4 and 0, I get a negative from the derivative. And here I'm going to plug in 1. So I plug in 1, I get a positive, positive, and positive. So it's above the x-axis. And one last to try, I'm going to plug in 3. So I get a positive, positive, and positive. So it still stays above the x-axis. All right, so communicate which critical number you're talking about. So if I'm looking at x equal -4, f prime changes from positive to negative. So therefore, f of -4 is a local max. And at the critical number x equals 0, f prime changes from negative to positive. So that must mean f of 0 is a local min.